Okay, here are your notes 6.7, being able to sketch square root graphs, including shifting it, and be able to sketch cube root graphs, including shifts with it too. I'm going to go kind of faster through these notes just because we went over a lot of this stuff in class. So this was basically just to let you guys know that y equals x squared, y equals x cubed. The ones that we're doing today are basically the cube root and square roots, which are the inverses of those two types of graphs. We went over what inverses actually means. Now these are the graphing forms of the two. Square root y equals a x minus h plus k, cube root y equals a cube root of x minus h plus k. Just like we went over in class, the h and k is your shift. A does the same type of stuff that it did with the squares. So horizontal shift, vertical shift. There's your h and your k. Just make sure this inside one is opposite. So once again, I'm just kind of going faster through these. Parent graphs of this. So just thinking of square roots, if you plug in a 0, you get a 0. Square root of 0 is 0. So square root of 1 is a 1. Try to pick nice and neat numbers. So like 2 is an irrational number, so is 3, but 4 you can find the square root of. Square root of 4 is a 2. Next one would be a 9, which would be a 3. Now when you connect all of those, it's kind of like it makes half of a sleeping parabola. If we were to draw on the other half, it would basically be down here, but we're not trying to get that right now because then it wouldn't be a function. So we're ignoring that piece of the square root function. The cube root, you can do a few points also. 0 is 0, cube root of 0 is 0, cube root of 1 is a 1, cube root of 8 is a 2. And if you connect those, you get half parabola also. Going that way, but you can, with this one you can actually go ahead and do negatives also. So for example, the cube root of -1 is -1, because -1 times -1 times -1 is -1. So the cube root of -8 is a -2, so that's over here. So you actually have another, it's kind of like another half parabola going this way. It's a cubic function, but graphed on its side. So those are the two types of parent graphs that we're going to be doing today. They're going to be shifted around, so it might be moved around just by the h and the k that we just went over. All right, so example 1, comparing graphs. So we know h and k are shifting. So your h here is a 1, your k is a -3. Now h is actually a -1 because remember inside opposite. So my shift here, if I'm taking the square root of x, and then I get to this one, that means that I shifted to the left one and down 3. So describe how to obtain the from the graph, that graph and the graph of that, you would shift y equals square root of x to the left one and down left one down 3. Okay. You could also say there is a horizontal shift left 1 and a vertical shift down 3. Same thing with this one, since the -5s are the same, cube roots are the same, the only thing different is your h and your k. So your h, remember, inside is opposite, so shift, so I'll put this one horizontal shift right 8. Yes, I know I'm not supposed to put capitals, but oh well. Right 8 and up 7. All right. And that's how you would do those. So you could have possibly a problem like that on your test. So let's move on to the actual graphing. So remember, this is your h, this is your k. If you look back at our graphing forms, right here, x minus h plus k, these are your vertical shift and horizontal shifts. Now, the way I'm about to show you how to graph this is only one way to do this. You don't have to do it this way, but it is a useful way of doing it. So what I'm going to do first is I'm going to ignore the shifting. Because if I ignore the shifting, then it's basically like I'm placing my graph back at 0. So it's not going to have any shift at all. So I'm going to make two tables. My first table is going to say y equals 2 square root of x. So if you notice, I took the 4 and the -1 off. Now your 4, remember, is a left 4 shift, and this is a down 1 shift. So basically, I took those off, so I'm starting my graph right back at the origin. Okay. Now we're going to pick some points. Keep in mind there is a domain restriction here because we can plug in negative numbers, but we don't want to get imaginary or complex numbers at this time. So let's just pick some positive x values that work nice and neat, so that we don't have to worry about imaginary things. So square root of x, let's start at 0. So the square root of 0 is 0. 2 times 0 is 0. Okay. to a 1. So the square root of 1 is 1, times 2 is 2. Now, if you put a 2 into here, the square root of 2 is not a nice, neat number. So let's try to pick nice, neat numbers since we're going to be graphing this. So perfect squares is basically what I'm saying. So perfect square, 0 is a perfect square, 1 is a perfect square, 2 is not, 3 is not, 4 is a perfect square. So if you take the square root of 4, you get a 2, but then you got to multiply that 2 by the outside, you get a 4. All right. So that is our graph without a shift. Now what we're going to do is we're going to apply the shifting afterwards. So now we're going to shift it. And if we're going left 4, so we're going to shift to the left 4. So if you think about left 4, that's actually negative 4. And if you think of down 1, that's a negative 1. Okay? So you're shifting left 4, which is minus 4, and down 1. So if you think about an x value at 0, if it's going to the left 4, then you're going to end up at 0 minus 4, which is negative 4. If your x value starts off at a positive 1 and you shift it to the left 4, it's like subtracting 4. So that's going to be at a negative 3. And if you start at 4 and then you move left 4, you're going to get a 0. The y part, we're going to move down 1. So all of these are going to be shifted down 1. So 0 minus 1 is a negative 1. 2 minus 1 is a 1. 4 minus 1 is 3. Now you can double check this too. If you plug in a negative 4 here into the original, negative 4 plus 4 is 0. Okay? Times 2 is 0, minus 1 is a negative 1. So if you plug these x values into the original, you'll actually get these y values out. This is just a kind of better way to understand what's actually going on with the graph. And I'll show you on the next slide what I'm talking about with that. So I'll dual page. So I'm going to graph this first one in red. So 0, 0 is right here. 1, 2 is right here. And then 4, 4 is up here. Now I'm going to make this dashed because that's not my actual graph. Try to connect all three of those dots, kind of like you're making half a parabola. All right. So what's happening here is that when we took the shifting off, we ended up with this graph that's centered right at the starting point's right at 0, 0. Now what's going to happen is all of these points that we just plotted are going to go to the left 4 and down 1, or basically these new points right here. So I'm going to graph these new points in blue. So negative 4, negative 1. So negative 4, negative 1. And if you notice, that is left 4, down 1. Okay. This is going to move left 1, 2, 3, 4, down 1, which is at negative 3, 1, which is what the point is. Negative 3, 1. And my last one is 0, 3, which is basically that last point. And you can make that line also right there. Okay. Now the red one, I'm not going to be grading you guys on the red one. It is helpful to know because there are certain tests where it asks you guys like what the shifting actually looks like, but that's basically it. The red one is just an auxiliary figure, it's a geometry term, to help us figure out where our new figure is. So I'm just requiring from you guys the non-shifted table and then the shifted table, and then just make the blue graph. You don't have to make the red graph, but it is useful. Okay. And that's basically how you graph. So I'll do one more example and then stop because that's basically it. So let's go ahead and do that's another square root, a cube root one. So let's try this one. So this one we're going to start off the same way as last time. So we are going to take the shifting off. First, let's make sure we know what's going on. So it's going to go left 2 and down 1. So whatever points we're going to make, we're going to move them left 2 and down 1 eventually. So my new table, my first table that I'm making is I just rewrite my equation 3 times the cube root of x. So just rewrite your equation without the shifting. Okay. And then what you're going to do is make a brand new table over here. And then you're going to put the shifting over here. So left 2 means minus 2, down 1 means minus 1. Now the nice thing about zeroing out your shift is that you start at 0. Now with this one, I can put negative numbers in because there are cube roots of negative numbers. So I'm going to pick some perfect cubes here. I'm going to pick negative 8 because there is a cube root of a negative 8. I'm going to pick a negative 1, a 0, positive 1, and positive 8. So if you notice on the square roots, I didn't pick any negative numbers. On the cube roots, I picked some negatives and positives here. So if I do a cube root of negative 8, I should get a negative 2, because negative 2 times negative 2 times negative 2 is a negative 8. So Cube root of -8 is a -2 times 3 is a -6. Okay. Cube root of -1 is a -1 times 3 is a -3. Cube root of 0 is 0 times 3 is 0. Cube root of 1 is 1 times 3 is 3. 8 is going to be 2 times 3 is 6. And if you look at your actual graph, there is a little bit of a pattern here, and there's as there should be. Okay. Now we're going to take all of these values, we're going to subtract 2 from them. So -8 becomes a -10, -3, -2, 1 minus 2 is a -1, 8 minus 2 is a 6. All right. Let me double check that. 10, -3, -2, -1, 6. All right. Next ones are my y's. So my y, I'm going to subtract 1. So -6 minus 1 is a -7. -4, -1, 2, and a 5. All right, so it is this one that's my actual graph, okay? This is the actual graph of that. The first one is just to help us figure out where to go. So -10, -7 is right here. -3, -4 is right here. -2, -1 is right here. -1, 2 is up here. And 6, 5 is over here. So you should be thinking of half parabolas. Now, I'm going to do the top part in blue. This is basically kind of like your quote-unquote vertex. So draw half a parabola going this way. Okay. And to make the other one, just draw half a parabola connecting these points this way. There shouldn't be like this little hump here, actually. A little bit nicer, like that. All right. And that's how you graph a cube root. You will notice some interesting things with the negative in the front, but we'll go over those once you guys start up your homework type stuff. All right, and we gotta say the domain and range. So the range here, range means how high up and down this goes. So I'll go back and do the other one also. So if I look at this graph, your range is actually all real numbers, because this graph, even though it kind of looks like it's flattening out, it actually keeps going up forever, and this keeps going down forever. And your domain goes left and right forever too. So your domain is all real numbers, and your range is also all real numbers. That's your domain and range of a cubic graph. All right, and little hint here, cubic graphs are always going to have that because you don't really have any restrictions. The ones that's going to start having restrictions is this one. Because if you notice, this one stops right here. It doesn't keep going to the left and doesn't keep going down. It basically keeps going this way, but then it stops right here. So your starting point is right here, depending on what you're talking about. So first off, let's talk about domain. Domains are your inputs. So what are you allowed to put in here? Now, on your x-axis of where you should be looking, my x-axis, my graph is starting at -4 right here on the x-axis. And then how far to the right does it go? It keeps going right forever. So all your values are greater than or equal to -4. So your domain is x's that are greater than or equal to -4. Okay, now let's do our range. Now, if you look at your range is how high up and how high down it goes, how far down it goes. Now, it only goes down to my y-axis right here is where it stops existing anymore down here. So my y is -1. Okay. All the way up to, and then it looks like it flattens out right here, but there's no asymptote. So it actually keeps going up forever. So it's going to go to infinity. Hold on, there's a phone. All right, so your range starts at -1, and then it goes up forever. So my range, I forgot my pen over here, are all my y values. Keep in mind, because this is y equals, my y values that are greater than or equal to -1. So that's your domain and your range part. All right, overlook that. So yeah, I'll give you guys a worksheet tomorrow to try this stuff out, and there you go. So tonight's homework is to finish off 6.6, the worksheet I gave you before, and to finish these notes off. Okay, bye-bye.